Hi, now we'll talk about position vector, velocity vector, acceleration vector, and finally we have force vector. Now, the position vector simply is x in x direction, which is I hat, plus y in j hat, plus k, z in k hat. We name it almost r as a vector. Velocity vector, which is v as a vector, is vx I hat plus vy j hat plus vz k hat. It is a velocity in each direction. Also the same for the acceleration vector, which is a as a vector, ax I hat, ay j hat plus az k hat. Simply, the velocity in general, the average velocity, is the change in position over the change in time. In each position, in each direction, Vx, Vy, and Vz, they are the change in each direction. For example, Vx is change in x2 minus x1 over t2 minus t1, and the same for the others. The acceleration is the change in velocity in each direction over the change in time. For example, if we read and observe, measure the time at initial point and the time was 5 seconds, and if we measure the time at the final point and the time was 15 seconds, then we have change in time, which is 10 seconds. We have point number 1, point number 2. This is change in position for a moving object. Now, point number 1, which is the initial position vector r1, and this is r2 or r final. This is x1, this is y1, this is z1, this is x1, y1, z1, this is x2, y2, z2. We need to compute the average velocity in this motion. An object moves from point to point during a time. So to compute the velocity in x direction, it is vx, which is x2 minus x1, x2 0 minus 2 over the change in time, which is 15 minus 5. So it will be negative 2 over 10, which is negative 1 over 5 meter per second. What about the velocity in y direction? It is y2 minus y1, which is minus 2 minus 3, which is minus 5. And the time period is 10, which is the same. Then the velocity will be in y direction is negative half. What about the average velocity in z direction? It is z2 minus z1, which is 7 minus minus 2. It will be 9 over 10, which is the total time, which is 0.9 meter per second. This is for computing the average vector from the average position. What if we need to compute the average acceleration from the velocity using these vectors? For example, if we have two vectors, velocity vectors, initial velocity and final velocity. This is the initial and this is the final. This is Vx, Vy, Vz initially, Vx, Vy, Vz finally. And we have time period is delta t, which is t final minus t initial, which is 6 seconds. Now we need to compute the acceleration in each direction. So ax is equal to vx minus vx, but finally minus initially, over the time period. Vx finally is 7 minus 3, it is 4, over the time period, which is 6. And the same for the vy finally minus vy initially, which is over the time period, which is 4 over 6 meter per second. And the same also for the change in velocity in z direction, which is 10 minus 0, which is 10, over the time period, which is 6. If we assume that the moving body has a mass 5 kilograms. We have acceleration, we have mass, then we can compute the force from Newton's second law. F is equal ma. Fx is equal to max, Fy may, Fz maz. So we can compute the force vector as we see from here, Fx, Fy, Fz, which is max, may, maz in each direction. And just we need to multiply m by the computed acceleration each time. Now, in this case, example, we compute the acceleration vector from the change in position and the velocity, and the average velocity from the change in position.